Hello, everyone. We're live. It's Tuesday and it's Hoot 51. And today, this will be a part two of the live stream I did 2 weeks ago, where I talked about Kubernetes networking and Cilium. If you're here, say hi, just so I know that people are listening and that you can hear me and that you can see me. I'll just click through to make sure that I am actually live. Looks like I am live, so that's good. Wait for a couple of more seconds for people to start showing up, and then we'll get started. All right, hey Anu. Thank you very much. Make sure you what do people say? Like, subscribe, share, or like, share, subscribe. Thanks. It's good to hear the feedback, so I know that we're doing something good and it's useful. So we'll continue doing the same. All right, let me switch to my slides. So I do have a couple of slides, and then I have a longer demo at the end. So today I'll be focusing on the network policy, Cilium network policy, and we'll talk about how that works, what is it, how it works. We'll look at observability a little bit, L3, L4, L7 policies, and that's what this episode is going to be about. And then next time, I'm either going to do a deeper dive into how everything works and how stuff is implemented, or we can look at some different topics. So if you have any ideas or preferences, leave a comment, let me know, and we'll do that. All right, so let's do a quick recap on what we talked about last time. So last time I gave an overview of Kubernetes networking. I talked about Cilium as well, and we talked about endpoints a little bit, right? So endpoint in Cilium is a collection of containers or workloads or applications that share the same IP, basically a pod, right? And by default, Cilium is going to assign an IPv4 and IPv6 address to all endpoints. And then either of these addresses, you can use them to reach that endpoint. Now, each endpoint also gets an internal ID, and that ID is unique within the cluster node. And there's also a set of labels that are derived from the pod. So the Cilium endpoint will get created whenever a pod gets started, right? And that's also going to kick off the creation of Cilium identity. So identity in Cilium is it's assigned to all the endpoints, and it's used for enforcing the basic connectivity between endpoints. Now, the identity of an endpoint is derived from the labels that are assigned to the pod. Also, if you change the labels on your pod, the identity of endpoints will get updated as well. Now, we know pods can have a lot of different labels, and not all of them are relevant for the identity. So there's labels such as timestamps or hashes. So what Cilium does is it's going to automatically exclude some of those labels that aren't relevant. But this also gives you, the user, a way to customize this and provide your own patterns for either excluding or including labels for identity purposes. Also, there are some well-known identities for endpoints such as the kubedns, core DNS, Cilium operator, and so on. And this identity is then used by the BPF to identify the endpoint and to enforce the policies. So I'll spend a couple of minutes just talking about the IP address management. I didn't mention this last time, but I didn't go into a lot of details. So the IP address management defines how IP addresses get handed out to pods, right? So if you remember last time, we installed Kind, and the default CNI that Kind uses is called KindNet. And KindNet uses another CNI plugin that's called Host Local, And that host local uses an IP range, and then it gives out the IP addresses from that IP range, and it also maintains a database of allocated IPs, so it knows what's available and what's not. Now, when we're installing Cilium, we have an option to pick which IP address management mode we want to use. So the default one that Cilium uses is called Cluster Scope, and Cluster Scope uses Cilium node resource, where that resource we can provide the CIDR range for specific nodes. There's also the Kubernetes host scope that's going to delegate the IP address management to each node in the cluster. So it's going to use the CIDR range that's defined in the node resource. There's also the CRD backed option, which allows us to delegate the IP address management to an external operator. And there's a couple of modes that are specific to cloud providers for Azure, AWS, and GKE. Last time also talked about the functionality that kube-proxy provides. So the functionality such as the in-cluster access to individual pods through a virtual IP, the service IP, the node port functionality that allows us to access the pods from the outside through the node IP and the port, and the load balancer functionality as well, which is typically done by the cloud provider. So what Cilium allows us to do is it allows us to specify the kube-proxy replacement mode. So we can configure Cilium in these 3 different modes. So Cilium can either completely replace kube-proxy functionality, or it can coexist with the kube-proxy in case Linux kernel doesn't support the full replacement. So there's 3 modes here. The first one is the called disabled, and this one is the default one. And this is where Cilium CNI doesn't have any involvement in the kube-proxy, so everything is delegated to the kube-proxy. The partial one, which is kind of in the middle, it's a hybrid setup where you can configure Cilium to replace some of the kube-proxy functionality, right? And when you're using the partial mode or the hybrid mode, you have to specify which functions you want Cilium to take over from kube-proxy. So do you want node port, external IPs, host port, and so on. And then finally, the strict one, which is a mode where Cilium is going to fully replace the kube-proxy functionality. So it's going to take care of handling the Kubernetes services for of type cluster IP, node port, load balancer, external IP, and so on. So you have this option, 3 options, right? Well, none or everything, and then the hybrid one where you can pick and choose what you want to use. All right, so this was kind of a more of a recap from the previous video, but we'll talk about network policy next. So I mentioned that network policy CRE ships with Kubernetes. However, it doesn't have an implementation, right? Cilium is here to provide that implementation. So what network policy resource, what allows us to do is it allows us to control the traffic at L3 and L4. So we can use the selector labels and select pods and then use ports in our network policies. Now, there's no L7 support. So when you're using the network policy resource, you can't inspect the packets. You can't use the HTTP methods, the headers or paths, for example. Now, at a high level, we can break down the resource into 3 parts. So there's the pod selector, and the ingress and egress policies. So using the pod selector, we select the pods we want to apply the policies to, right? So note that the pods that we're selecting here with the pod selector are in the namespace where this network policy is going to be deployed. So it's not cluster-wide, it's namespace specific. And then the ingress policies or policies for the ingress traffic, right, are basically saying, hey, I want to apply these policies to these specific pods, whatever was selected by the pod selector. It's basically saying whoever calls into these pods And then the egress policies is basically saying whenever these pods that are selected by the pod selector make calls outside, make egress calls, right? So that's when the egress policies are going to be applied and used. So here's an example of a network policy with these three parts, and at the top we have the pod selector that's basically telling us, it's saying, hey, the ingress and egress policies, or the policies that we define in these in this resource, will apply to any pods that have the role DB label set in the default namespace. Note that the policy is has a namespace set to default, so it's going to be deployed to the default namespace. So if we had a pod, let's say with the same role DB label set and running in a different namespace, this policy is going to be deployed to the default namespace would not apply to that pod at all. After that, we're defining the policy types. This specific resource has both ingress and egress policies, right? And the ingress policies are first, and they're telling us which entities can call the pods that have the label role DB set, right? So if you try to translate what this policy is doing, we can see that there are two, let's say two high-level sections. We have the from field, and then we have the ports field. So the ports field is saying that it's basically specifying to which ports on the role DB nodes, pods, right, is ingress allowed, right? So in our case, it's the port 6379. Then the from section is specifying who can make the calls to the pod, or from where the requests can come from. And again, if we break this down, there's three sections here: the IP block, the namespace selector, and the pod selector. Since all three are items in the from field, notice the dashes before all of them, it's going to be the or semantic that's going to apply, meaning it's going to be or IP blocks, or namespace selector, or pod selector, right? So it's not and. The way that you do and is you don't make that part of the previous block. So the IP block section basically allows us to specify a CIDR range, and we can say, in this case, we're saying, so all IPs from 172.17.0.0 to 172.17.255.255, except for the IPs between that specific CIDR range, right? So this IP block is saying, hey, if your IP is anywhere from this, coming from this CIDR block, then you're good. It's going to evaluate to true. The second one is the namespace selector, which is just saying the calls can be made from a namespace with a project label set to my project. Hey, Viral, welcome. No worries. It's all recorded. No worries to be late. And then the last one is the pod selector, right? Similarly as the namespace selector, but it applies to the pods, and it's saying, hey, only pods that have the label role front end set can make the calls to the pods that have the role DB label set. So as I mentioned, these three conditions are ORed together, meaning as long as any one of these three parts is true, the request will be led through to the role DB, right? So any of these three conditions should be true, as well as the port has to be 6379. Right? And then we can do the same for the egress portion, right? So the egress portion is going to apply for the calls that are being made from the role DB pods, right? And notice this time we have the ports field as well, which is set to 5978. And this time we have the to field instead of from, right? So we're saying egress to, in this case, we have the IP block, right? Which is telling us these are the IPs that these pods, the role DB pods, can call out to on port 5978. Right? So here's a different view of the network policy, right? As I mentioned, the policy allows us to control L3 and L4, right? It's broken down into these three parts. The selector, which is saying apply the policies to these pods, and then a separate ingress and egress sections that's saying who can call in and who can call out, right? Any questions so far? All right, I'll be looking at the comments if there's anything, so feel free to ask at any time. So this is the network policy API, basically the whatever comes with Kubernetes, right? And it's implemented by Cilium. So what are some of the shortcomings, right? So first one is that it only supports L3 and L4. So there's no L7 support. You can't use HTTP methods, right? Or URL paths, headers, and so on. It doesn't do anything TLS related. So there's no also node specific policies, right? You can't log any security events. So, for example, when the connections are accepted or blocked, right? You can log those. Also, you can't do deny policies, right? So all the policies that I talked about by default are allow, meaning we're explicitly saying what's allowed. We're not saying what's not allowed, right? What's not allowed is implicit, right? It's said by what's allowed. And there's also more. I added a link at the bottom that the Kubernetes page actually goes into. Let me see if I can open that one. Yeah, so this one goes into more details, like what's allowed, what you can't do, right, with the network policies, what's not implemented yet, right? So, what does Cilium bring us or bring to the table, and what can Cilium do? Well, the first one is it does implement the network policy CRD, right? So, if we wouldn't install Cilium CNI, we couldn't even do the network policy CRD, right? So it allows us to do that, allows us to use the L3 and L4 policies. And then on top of that, it also brings in two new CRDs, Cilium network policy, which is very similar to the network policy, but it provides more functionality. One of them being L7, right? So whenever Cilium is going to detect an L7 policy, it's going to spin up an Envoy proxy inside the Cilium agent pod, right? And I'll show that in the demo. And then that L7 pod, L7 Envoy proxy, right, is going to enforce all policies on that specific node. Now, on top of the Cilium network policy, there's also Cilium cluster-wide network policy. And then the difference between these two is that the cluster-wide resource, as the name suggests, applies the policies cluster-wide, and it enables us to use things like node selectors, right? Remember, the default network policy is namespace only, so there's no way to apply it across the cluster. But with the Cilium cluster-wide network policy, that's what we can do. All right, so here's I tried to make the slide look very similar to the network policy one that I had. So let's look at the differences that are there. Now, the first difference is with the selector. So we know Cilium has the concept of an endpoint, right? Therefore, the selector is called an endpoint selector. However, it still uses the match labels, right? And it's not necessarily any different other than the name. Now, the ingress and egress portions have a lot of extra and added functionality. So instead of having a single from section, there are three, well, not three, there's three, let's say 3, 4, right? Dedicated from sections that you can also combine, right? So there's the from CIDR and from CIDR set functionality that's equivalent or similar to the from IP block section in the network policy. So we can specify the CIDR range and also option to exclude the CIDR range, like I showed before. There's the from endpoint field that allows us to specify the match selector, and it's similar to the pod selector option in the network policy. There's also the from requires field. So what from requires allows us to do is to define some base level requirements for any from endpoints condition. So what does that mean? So you could, let's say we specify in the from requires, we specify a match selector for app equal prod endpoints, right? So what that's doing is telling us that any endpoints that are also selected by the from endpoints must have this app prod label as well. So the way that I see this is almost like a pulling out requirements, right? In a way like a refactor, right? So we're pulling out some common labels that we would otherwise have to specify in the from endpoints. And then we're just specifying in the from requires section, right? So we can say, hey, all these things have to have this, let's say, app prod label. And then in the from endpoints, you can specify different ones as well. There's also the from entities section that allows us to describe the different entities that are part of Cilium, right? And these entities are defining, right? We can describe the entities that can access the endpoint selected by the endpoint selector. So there's multiple entities defined, things like world, meaning everyone, cluster, host, remote node, and so on. There's also the to ports field, right? And this one allows us to specify the ports for the policy as well as the protocol. Now, on the egress side, we have similar fields. So we have the two-sider set, right? Two endpoints, two entities. But there's also two egress specific, I guess, fields. One is called two FQDNs, and the other one is called two services. So the two FQDNs allows us to specify a fully qualified domain name. So we can say to hello.com or star.hello.com, and then do the matching and policies based on that. The two services one is similar, however, is specific to Kubernetes services. So we can use it to either target a Kubernetes service by its name or target a Kubernetes service using label selectors. Now, in addition to these allow policies, there's also deny policies. They look more or less the same, but instead of you writing allow policies, you're writing deny policies, right? Also, the other thing that I wanted to show here, let me actually open this, is this network policy editor. And this was very helpful when I was trying to like dig in and figure out what the different features are. So what this one allows you to do is allows you to visualize, visually create your Cilium network policies, right? So we can do something like this, and then we can do ports, let's say 8080, that rule. And what this is going to do is it'll create a YAML for you, right? So this one gives you a way to like show all these different, look at all these different features, right? So let's say to FQDN, we'll say example.com on port 80, add rule, and you'll notice that it's going to add the egress section with the match pattern with the specific port, right? All right, let's go back to the slide. So I have two more slides, I think. So how about L7, right? So I was mentioning the L7, right, being supported as part of the Cilium network policy. So you can write the L7 policies inside of the rules field or rules section that's inside the two ports, right, field. So what you can do is you can match on path, method, host, and headers. Someone is asking for a link. Yes. So it's editor.networkpolicy.io. So let me type that in. Editor.networkpolicy.io. There you go. Can also do this. Yeah. So the only thing that I think as I was going through this, the network policy editor and docs, I don't necessarily think that this is fully up to date. I'm blanking out on what specifically it was, but I think there are some things that I didn't see here in the UI, but I might be wrong. But anyway, it's a good way to to look at this, right, and figure it. It's easier to write the policies maybe like this than just purely go to YAML and do it there. All right, so L7 stuff, right? Basically, in the two ports section under the rules field, match on path, method host, and headers. In the example here on the slide, I have it's basically saying, hey, any endpoints with the app hello world label can receive packets, right? Because it's ingress to those pods or endpoints on port 80 using TCP. And the only methods that are allowed are the get method on the /API path and a put on version, right? Put method on the version path when the X sum header is also set to true, right? So this is the difference between, so it's or, and then within that put, it's and, right? So this is how you would write like an example L7 policy. And then just the short one on the Cilium cluster-wide network policy, same functionality more or less as Cilium network policy. However, like we can specify the ingress and egress, of course. However, instead of applying the policies at the namespace level, it allows us to apply the policies at the cluster level, right? So it's one or more nodes, and it also allows us to use node selector to pick specific nodes, right? So similarly as we would use the endpoint selector, right? And then you can use one or the other. All right, so let me switch to the demo in the correct window here. Let's see. Problems of having too many windows open. There it is. All right, let me know if the font is big enough. All right, so what I'll do, let me just make sure that we have a clean slate. All right, so I'll create a kind cluster, and this is the same thing that I did last time. We'll use 3-node cluster. We'll disable the default CNI. We're setting it to true, and we're setting the kube-proxy mode to none because we want Cilium to handle that. So I'll just do kind create cluster kind noci.yaml. It's a bit blurry. I don't know if I can control that. Sorry. Make it a little bit bigger if that's, not sure if that's going to help, but hopefully this makes it a little bit better. So this should take a couple of more seconds. I should have done this before the stream. All right, there you go. So we have a cluster. So let's look at the nodes. You'll notice that the nodes are not ready because there's no CNI, right? It doesn't know how to give out the IP addresses. And then the same for core DNS, right? For example, core DNS pods, they're in pending because they don't have the IP addresses. So what I'll do next, I'll install Cilium, and let me just show this. This might be too much or a lot of stuff here, but I'll explain it. There you go. So I'll use this values file because I'll use Helm to install Cilium. Bigger is better. Thanks. All right, perfect. I'll zoom in as I go through this. All right, so I'll use Helm to install Cilium, and I'll pass in this Cilium values file. And what I'm doing here is, let's just go through this. So I'm enabling Prometheus operator because later on I'll show in the demo the observability portion, right? So there's the Hubble, right? Hubble UI, Hubble CLI, and it also allows us to export the rich data that it gets from BPF as Prometheus labels, right? So we're enabling this. We're setting the kube-proxy replacement we talked about to strict, so CNI is taking care of everything. Because we're doing that, we have to tell Cilium where to connect to, right? So we're passing in the control plane, node name, and the port. We're enabling Hubble, we're enabling Relay, we're enabling Prometheus, we're also enabling UI. We're enabling open metrics, and then we're specifying the metrics that we want to collect. So we'll see all these later in Grafana. So let's do it this way, and I'll just paste in the command, which is just helm install 13.2 to kube system, and then pass in the Cilium values file. There you go. And then I separately installed the Cilium CLI. Sorry. And let's do the Cilium status. And this is you can use this to basically check what's the status of the Cilium installation. This should take a couple of seconds. Shouldn't be too long, I guess. Try again. All right, almost there. A couple of them are still unavailable, but we're almost there. Let's try again. Hubble UI, almost. There you go. So all is green, all looks good. That's what we like to see. So I'll also deploy Prometheus and Grafana. So this is just coming from the examples, from the add-ons from the Cilium repo. So we'll do that. We don't have to wait for it necessarily at this point, but it just creates Grafana and Prometheus for us with some pre-configured dashboards as well. All right, so now we have a cluster with Cilium installed. I'll deploy Sleep and HTTP bins. Note if you're using Sleep, I haven't checked. I noticed earlier this week that the latest version is not supporting ARM64. There's a bug or something, so they're fixing it. So if you were using like sleep.yaml, like I did from Istio's samples, that one's not going to work if you're on ARM64 because it doesn't have this specific version there. But anyway, let's move this up here and let's see. Let's look at the pod. So both of these are running. And then if we do send a request from sleep to HTTP bin headers, we get back the response. So that's expected. All right. So the first thing we'll do is I'll create a default deny ingress policy. And let me just paste it here and then we can talk about it, right? So network policy, we're calling it default deny ingress. We're setting the pod selector to curly brackets, basically empty, meaning select all the pods in the default namespace, and we're specifying. We're saying that there's going to be policy type of ingress, but we're not specifying the actual thing, which basically means deny all traffic between the pods inside of the default namespace. So if we would try to send that same request like I did before, this is not going to work, right? Because that network policy, Cilium is basically enforcing that network policy and is denying ingress, right, between ingress to HTTP bin, right, in the default namespace. So next thing that I want to show, and I'll just let me open our terminal here. And what I'll do is I'll use Cilium Hubble port forward just so I can connect to the Hubble that's running inside the cluster. And then we'll leave this as is, and I'll switch back to the original one. Notice that this one got terminated. So what I wanted to show you here is this observe Hubble CLI with the observe command. And we'll do to namespace default. So what this one will show us, let's do another window, and I'll just make a request here. So if I go back, you'll notice that we got some information from Hubble, and these are basically the network flows that are happening or that the Cilium is tracking, right? So we see the there's a sleep pod, right? Core DNS, kube DNS, sleep pod again, and then basically the ingress denied here, right? It's telling us that call from sleep to default was denied, right? And a connection was dropped, right? There's also an easier, well, not an easier way. So let me show you this JSON format. And what I'm doing here is I'm running the same observe command. I'm just getting the JSON output. And what the Hubble CLI allows us to do, and these are just a couple of the filtering options, right? So we can specify different options or filters, I guess. Observe, let's do help just to show that. We can show the exact FQDN. We can do filters on FQDN, IP, labels, namespace, pods, ports, services, workloads, method paths, right? So there's a very rich set of filtering that we can do with the CLI, right? In this case, I'm just saying, hey, I just want to observe everything that's going on that's coming from app sleep and going to app bin, right? And this gives us, let me just copy one and let me see. I'll do it here. Oh, actually, no, I can just do Q, right? Yeah, there you go. So this just shows you all the rich information that's collected by Cilium, right? So Cilium collects these flows. They're calling these flows that have information about source, destination, ports, IDs, identity, right? So these are the Cilium endpoint ID, Cilium identity, namespace, labels, the actual workload, where is it coming from, right? It knows that it's a sleep deployment. And then the same thing for the destination, node information, traffic direction, and then the reason why it was dropped, right? It was policy denied because we had that policy. So all this context that's in here in this flows can also be extracted out and presented as labels in Prometheus, and I'll show that a little bit later. On top of that, there's also a UI component. Oh, it's Cilium Hubble UI. Let me do that. Waiting for it to open. I have it here. Let me quickly share that one. Hubble UI. There you go. And we'll look at there you go. So this one will just show you the same similar things that we've seen in from the Hubble Observe, right? From that output, those flows, but it's going to visualize it, right? So it's going to show us that, oh, we made a couple of calls, right, from sleep to HTTP bin on port 80. And then down here is also just going to show us all the request has been forwarded to, like, from source to destination, right? But then it was dropped here. Trying to zoom in, right? Verdict was it was dropped, and the reason was because the policy denied it, right? So all the rich information that we saw in that JSON, right, is over here visualized. And this one also has, let me see if I can refresh. Oh, is it because I was zooming in? It looks like I messed up my. Wait. Oh, there you go. You can also do filters up here, right? So it has a. Let me zoom in if I'm not going to mess it up. There you go. Right. So it allows you to do filters and say whatever label app equals. Oops. App equals sleep, right? And then we only have one, right? So it shows up, but it's a visual way to show those flows. All right, let's go back to. That was this one, right? Yep. All right, so let's cancel out from this one. So where are we? So if we created the policy, right? Let's look at it. Default deny ingress that allows denies ingress to pods in the default namespace. So what we can do now is let's explicitly allow traffic from sleep to HTTP bin endpoints. And the way that we could do this, so you notice we're layering things, right? We have the default deny. Now we're layering another network policy on top of it, and we're saying allow ingress to HTTP bin. So this one is again selecting the HTTP bin workloads, and it's also specifying ingress, and it's saying, hey, if the calls are coming or if the requests, the packets are coming from the pod with the app sleep labels, then that's allowed, right? Because it's an allowed policy. So if we try the request again, should have just typed it. Oh, there it is. This time it works again, right? So it's going to be allowed because we specifically allowed it. Now, let's say we create namespace called sleep and we deploy another sleep workload in that namespace. So we have a sleep workload in the sleep namespace. Now, if we would send a request from this namespace, sleep, and this time we have to do .default because we're calling across namespaces, this one will fail, right? And this is just showing you that we're basically, the policies are namespace specific, right? They have to be applied to the namespace. However, what we could do is we could create another policy. And this time, this one is allowing, again, it's applying to HTTP bin, and it's allowing calls, and it's using the namespace selector from any namespace with the name sleep. There's only one, right? So let's do this. And this time, if we call it from the sleep namespace, this time it's going to work, right? Now, if I look at that policy again, I'm just going to do apply just so we can look at it, right? What this one is actually saying is, well, we don't really care which pod the call is coming from. We're just saying as long as it's from the sleep namespace, right? The way that we could tighten this up and say, hey, it has to be sleep namespace and it has to be sleep pod is to add a pod selector as well, right? So this is saying any calls from the sleep namespace and from the pod that has the app sleep set, right? So if we retry, this will work. There's not going to be any difference, right? All right, so let's clean this up. So I'm deleting all of the things that I deployed, and now we did a blanket denial of all the ingress and egress traffic right within a namespace. However, a better way would be to maybe create a policy that automatically allows all traffic right within the namespace, but then denies traffic from other namespaces. So let's see how we could do that. So I already applied it. So we're again using an empty pod selector, which means apply to all pods, right, in the default namespace. And we're also saying allow ingress from any pods as well, right? So this is basically allowing all ingress within the namespace, right? So if we would deploy if we try the send the request now, right, from the sleep is not going to work, right? However, if we do it from default, this will work, right? So it all depends how you want to lock down your namespaces, right, and how you want to apply the policies. So let's do egress as well. So we'll create an egress policy that's going to deny, is going to be applied on the sleep pods, and it's just going to deny any egress from the sleep pods, right? So if we try to repeat that same request, it's not going to work because it's denying making a call to anything, right? Making an exit call. However, one thing you might have noticed here is that it's saying could not resolve host, right? So it is kind of denying, but it's also denying the request to the DNS, kube DNS or core DNS rather, to resolve the name. So the way that we could fix this is to we're saying allow egress to kube system namespace and to any pods that match the kube DNS label. Do this. This is now going to allow the DNS resolution to happen. However, we still have that blanket policy in effect, so it's not going to let us do the call. All right, so let's do L7 quickly as well. We're close to time. There you go. So let's clean this up. I'll also have to show the Grafana and Prometheus. So let me do that. So go here. So I'll cancel out and I'll go to bin sage, and then I'll just going to run 3 endless loops. They'll continue making calls to /post endpoint /headers endpoint and IP endpoint. And then we'll apply some. This is just so we can generate traffic so we can see it in Grafana. And I'll explain this through the rules, right? So let's try this. So we're just making a post request. This works, right? We're also, if we make a request to /IP endpoint, this is going to work as well. So what I'll do is I'll deploy a policy that only allows GET requests to be made to the /headers endpoint. But before we do that, let's just quickly show the. Let's do this. Just want to show you what's running inside of the Cilium agent pod, right? So I'll grab this one and we'll do kube system and just let's, oh, of course, typo, sec. All right, so notice there's Cilium agent and Cilium health responder, right? So what I'll do now is we'll apply the Cilium network policy because we want to use L7, right? We're saying allow get headers. We're applying it to HTTP bin, and we're saying we're allowing calls, we're allowing ingress from the endpoint with the app sleep label to the port 80. Notice I have a note for myself here as well. We're using port 80, even though the Kubernetes service is on port 8000, right? However, the endpoint port is actually on the pod, right? It's port 80. And then we're specifying the rule that says only allow ingress to port 80 and the method get and the path headers, right? So let's do this. So if I go back to this guy, you'll notice that we're getting access denied call responses now here, right? Previously, we're getting the responses back all good. So if we try to send a post request, so let's do sec deploy sleep, and we'll do post request, we get access denied, right? However, if we do get on headers, that's going to work fine. And then we can also try like get on IP. We're also going to get access denied. So let's look at this in Grafana. So I'll just do port forward and we'll wrap it up. All right. And let's open it and share it. Grafana. Oh, this doesn't look. And Grafana, if you go to dashboards, if we look at the Hubble metrics, and then I'll do last like 5 minutes, and you'll see that we can see actual L7 requests that are being made, and this is what Cilium is exporting to Prometheus, and then the Grafana is using Prometheus as its source, right? And then is just visualizing the data, right? So you can see the default sleep with 200 responses and default sleep with 403 responses that were happening here. Income request volume, success rate, duration, right? Just a different graphs basically that shows you show you all that all those metrics, right? There's also Hubble metrics that you can look at, right? These are very like specific things. Cilium operator, CPU usage, memory. Hubble, we looked at the Hubble one. What else is here? And then just a general Cilium metrics. All right. I think that was it for today. Let me just check my slides just to make sure. No, this was it. I hope this was useful. So we showed the network policies, right? How they work. Talked about what Cilium brings to the table, and then showed the demo. You can go to the link at down here, bit.ly solo-hoot. That just links to our GitHub repo, and I'll be posting the demo that I did today over there, so you can go through it yourself. Also, if you have any specific topics around Cilium, let me know in the comment. Let me know on Twitter, or you can also come to our Slack. You can find me there, ask questions. I know someone was asking questions, very specific question. I think it was Nikhil. Nikhil, if you're listening, join the Slack solo, ping me there. I want to hear more about your scenario, and then we'll figure it out. And then for next time, I'm either thinking doing like IPsec, WireGuard maybe, or just do a deeper dive into how, like maybe eBPF even, right? And how all this is implemented. But anyway, let me know. Hope this was useful, and I'll see you next time. Thanks.